So I want to talk about this notion of fostering a culture, fostering a microservices culture. What does that really mean? Culture is kind of a squicky thing. It's like we don't really want to talk about it too much, right? We're engineers, we're systems people, stuff like that. We would really kind of not want to talk a lot about people and how they behave and how you can't control them and so on and so forth. But actually, this is really fundamental to the work that we do every day. It's how we interact with everyone in the world, and when we're in a process where we're actually trying to create output, we're trying to build something together, this idea of culture becomes very important. And in the simplest way of thinking about it, I don't have the quote up here, but there's a great line from one of the sort of the fathers of this DevOps thing, and he says, culture is the way we do it. It's just the way we do it here. Everyone's experienced culture. You come into a new job and somebody says, no, 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 that's not the way we do it here. Let me show you how we do it here, right? They're teaching you culture. Culture is how many emails you send. Culture is how many people have to approve something before you get it done. Culture is how fast you can get something done. Culture is how you communicate with each other, how you treat each other, how you're expected to respond, and so on and so forth. This is culture. So an effective culture is incredibly important in an IT environment. This is a quote from MS Research, Microsoft Research Group. Organizational metrics have a prediction and precision rate of 85% of the error proneness of your code. 85% accuracy, repeatable, based on the organization, not on the lines of code, not on the number of units or modules or language or any of that stuff. Error proneness can be predicted by your organizational metrics, the way your culture works, the way your organization is arranged. So what is an effective culture for this new thing, this microservice thing, this stuff that Matt talked about, stuff that Lou showed us in examples, and that Irakli talked about from a product standpoint? So what is that like? So one of the writers who's really done a really good job of starting to encapsulate what microservices is about is a guy by the name of Sam Newman. And this is a quote from a blog post that Sam wrote this year. Microservices allow organizations to align the architecture of their system to the structure of their teams. That's a big deal. Systems and teams, that's a real key to success in this space. It's always been a real key to success. A lot of this comes out of the notion of project management. We got project management in the 60s when we were doing the big shot projects like Moonshot and all these other things. We were getting all these people together. We need to understand how people work together. So this is a real important aspect. Now, what's really interesting is the title of the blog post is called Demystifying Conways Law. And Matt has already talked about Conways Law already today. And so we've been introduced to this idea a couple of different times. So I thought it might be interesting to take a few minutes to see who Mel Conway is, this person who's been credited with this law. By the way, he says he never thought of it as a law. It's not a law. He says it's more of a principle or a guideline. Sort of like the Pirates Code, you know? It's not a law. It's just sort of a guideline. So this is Mel Conway. Mel Conway worked for Remington Rand and Burroughs Systems in the 60s when this project management idea was first starting to come together. So Mel Conway comes up with this notion. He's really curious about how people interact. But Mel Conway is actually a very interesting character. He's had lots and lots of interesting jobs. He created an assembler system called SAVE for the Burroughs computer. That SAVE didn't actually stand for anything, but it meant that every punch card was marked SAVE on it so they didn't get lost. All right, Mel already understands how people behave. He writes the first universal compiler language for mainframes in 1958. In 1958, Mel Conway is writing the Java runtime. He's writing the universal runtime in 1958. And Uncall today is still sort of used as a model of thinking about how you can have a universal compiler system. He writes the first paper on coroutines in 1963. Coroutines become incredibly important. Long before we understand about subroutines and stacks and all these other things and what's shared and what's not in memory and pointers, he writes the definitive paper. And coroutines are still today talked a lot in functional programming and lots of other things. He writes an article called How Do Committees Invent in 1967. He's involved in the MUMPS. Anybody ever touch MUMPS, the MUMPS systems? I did MUMPS systems. So MUMPS systems is the medical computing platform for IBM. He's actually instrumental in designing and documenting it. He writes the Pascal compilers for Mac and Apple. He becomes an Apple Fellow. He's currently working on a thing called Humanize the Craft. Humanize the Craft with this idea. He has this phrase where he says, typing is an unnatural act. We need to rethink programming. He's an incredibly creative guy. And he, of course, like, this is the 2010s, so he's still around. He's not gone. We're going to talk about this one thing. We're going to talk about this paper, How Do Committees Invent, that he wrote in 1967. This is the one that everybody seems to remember. He told me once, you know, I did other things. But this is the one that everyone remembers. So when he's working at Remington Rand, he's in this process of back when mainframes, we actually built mainframes to spec, right? Like we build code to spec, we built hardware to spec. This is the mainframe for the SAGE, for the semi-autonomous ground system. This is the mainframe for Sabre. This is the mainframe for this and that. We would build them to specs. And he noticed how people come together and how teams work. And he gets really interested in this notion of a project-based organization. We do project management because of what was going on in the 60s. It's a great journal which talks about it. Project-based revolve around the concept that a group of individuals have explicit jobs and they come together for a certain thing. So he writes this paper called How Do Committees Invent? It gets published in a Datamation magazine. Originally, he submitted it to Harvard Business Review, but it was rejected. It's a long story. It's an interesting one. But he writes this paper. And in it, the punchline to this paper is this one line. It's kind of a complicated sentence. Any organization that designs a system will inevitably produce a design whose structure is a copy of the organization's communication. That's a lot. A system's design is a copy of the organization's communication. Or better yet, communication dictates design. And this is inevitable. Over the 50 years, almost 50 years since he first wrote this piece, study after study, including sponsored by the Harvard Business Review, has proven this to be true. The way we communicate dictates what we produce. And that's now known as Conways Law. It's known as Conways Law because of this man. Who's read this one? Mythical Man Month. Everybody should be raising their hand here. This will be on the reading list. So Fred Brooks writes this book called Mythical Man Months, and he mentions Conways Law in it. He mentions Conway's dictum, and he calls it Conways Law. But we actually know Fred Brooks for this one. We've all lived this one every day. Adding manpower, person power, to a late software project makes it later. We all know this is true. But we're never going to make the deadline. Add 20 more programmers. Yeah, that'll work out great. So both of these men are thinking about the same thing. Both of these men are thinking about how we get people to solve a problem and how those people interact. Basically, Fred Brooks talks about this notion of the intercommunication problem. When you've got an X number of people, there's going to be this possible number of set of communication. And notice you go from 5 to 15 to 50 to 150. You basically go by order of magnitude in a more complex communication model. You've got 150 people on a team and you want to get them all going in the same direction, you've got to deal with this number. If you can get that team down to 5, that's actually pretty manageable. This is the first place where Microsoft's research kicks in. The team organization affects the error proneness of things. Now, those numbers are actually kind of interesting. 5, 15, 35, 150. It's a gentleman by the name of Robin Dunbar. Anybody ever heard of this gentleman? Wow, very cool. Measurement of the cognitive limit to the number of individuals with whom anyone can maintain a stable relationship. How many friends can I maintain? This has become known as Dunbar's number. It was originally thought to be incredibly important for people like Facebook and all these other things. Dunbar's number is pegged at 150. Dunbar spent a whole bunch of his time studying primates and the primate group size and comparing it to brain size, blah, 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 blah. We won't spend a lot of time here. But basically his theory is that the size of our brains is governed primarily by our need to interact in groups. The bigger the brain, the more we can more people we can maintain stable relationships with. And he basically says the sort of the magic number, a stable number, is 150. He's got names for all of these in different lights. There's trusted and casual and so on and so forth. So that 150 becomes kind of important. Intimate, trusted, close, and casual. His theory is you have these number of casual friends, and if somebody else comes along, you boot somebody else out of your little group, right? Now, most online systems now augment us, so that's why we have hundreds or thousands of LinkedIn connections and so on and so forth. It's become a sort of a different model, and it actually reaches into some of his other zones. You saw up there 500 and 1,500. We won't talk about those today. But Robin Dunbar is talking about this list of numbers, and he's talking about our cognitive ability to communicate. And those numbers look incredibly like Fred Brooks, because Conway points out communication dictates design. And I can start to think about the way our teams are constructed now. And that's going to affect what's produced. So it turns out, this is really what I call Conway's first law. This paper, which is only about 4,000 words, it's just a couple of pages. You can find it online if you just look up Conways Law, or How Do Committees Invent. There are a couple of other really, really good ideas in there, but the first one tells us that team size is important, the size itself. Not that I have a real genius person and she'll run the whole thing, or there's a couple of laggards. Size, just plain size, is important. So we need to make the teams as small as necessary. So that's the first rule. We need to make teams as small as necessary. Spotify has a great adoption of this idea of team size, and it gets kind of complicated. There's a paper called Scaling Spotify, which will also be on the list. Basically, they arrange their tribes as somewhere between around 5 to 7 people in a team. They also have these ways of cross-connecting tribes, like all of the people who are the ops persons on these teams, or all the people who are the designers, all the people who are the HTML or the CSS people, can still talk to each other. They don't become silos. It's a really interesting paper, but they've totally adopted this notion. And they claim it's not only increased their agility, it's increased their quality, just because of what Microsoft talks about. So here's the first guideline. If you don't have a personal relationship with every member of your team, that team's probably too big. I've actually been in rooms when I've heard a team leader say, who's he? Is he on our team? That's a bad sign. That's a bad sign. I don't have the slide up here, but Albert Gore-Tex, the person who invents we used to work at DuPont and he invents the material, he used to have a rule that says when you create a building, when you create a manufacturing plant, you can only house 150 people in that plant. Because he used to say, back in the 70s, because I can only remember 150 names, so if you have 200 people, make 2 buildings, even if they're next door, and split them up. He was so adamant about this notion about the team size and what you could remember and what you couldn't. So our guidance is aim for a team size of what we call Dunbar level 1 or 2, 5 or 15. Basically squads. If any of us have ever worked in the military or even played first-person shooter games, you get sort of into this notion. And we have this experience, we know this. Those of us who worked in a small team, like maybe we lucked out and we were like 4 or 5 of us, and we didn't have to communicate. We sort of knew exactly what the other person was doing, and this was this really amazing experience. And startups are very much like this. That's why startups don't start at 150. They start relatively small. They're fast, they're agile, they communicate well. As things grow, there are new challenges to the way you manage communication. We won't get a chance to talk about them today. You can manage communication for 150 and 35 and 50, but it's very different than how you manage it for 5 or 15. So as things grow, very often startups can't scale their communication model, and they start to break up. They start to fall apart. Problems come in. And that affects code, that affects output. Okay, so what about the other Conway laws that I alluded to that are in this same paper? Here's what I call Conway's second law. It's about doing it over. There's never enough time to do something right, but there's always enough time to do it over. We know this, right? The most typical version of this is, that's okay, we'll do it in version 2. Right? We do this. We have to decide. Now, we're not going to get this done, but I promise you, next time, we'll get that feature in. What happens is we engage in trade-offs. And in a successful IT culture, you need to actually engage in trade-offs all the time. There's this great book, there's this great concept called Efficiency, Thoroughness, Trade-Offs by Eric Holnagel. It's a very easy read. Eric is sort of a hero of the DevOps culture because Eric and several other people in his area talk a lot about system resiliency and handling errors and failures and all sorts of other things. And this is a really, really good book that sort of covers the basic of that. The efficiency, thoroughness, trade-off principle. And there's a lot in this book, but the two things I wanted to point out is he points out the difference between satisficing and sacrificing. These are his ways of explaining it. Satisficing is explained as a consequence of limited cognitive capacity. I just can't deal with all of that. It's too complex, it's too involved, there are too many people involved, so on and so forth. Sacrificing is different. The intractability of the system. I can't get the system to move fast enough or get things done. It's intractable, it's immovable, it's implacable. So simply, the problem is too complicated, I'll ignore the details. That's what most of us do. Matt was sort of giving us this story about how we tend to not address the idea that we're actually creating complex systems. It's more like I'm building an application. We skip the details because they're really complicated. But the other one is not enough resources, I give up features. I don't have enough people on my team. Lou was talking about this specifically this morning, about the idea that eventually you're going to have this issue of scaling your team. Not just the code, but can we support that many units of service and so on and so forth. So problem too complicated, ignore details. Not enough resources, give up features. This is normal. This is the way we operate. We always make this trade-off between efficiency and thoroughness. Hollnagel also talks, this is the other one I talk about, the idea of safety 1 and safety 2, and this is really the way it works. Safety 1 is trying to get rid of all the possible errors, all the possible bad things in the system. That's really what a lot of us design our culture to do, to find bugs and get rid of them. The problem is you never get rid of all of them. You never do. What you do is you stop. You make a trade-off. It's like, you know what, if I can't find one, or if the count of bugs per lines of code is lower than X, we stop, because the cost of fixing that next bug is so high. But he introduces a different concept instead. He says in safety 2 and resilience, you add as many good things as you possibly can. What you do is you build a system that continues to operate under failure. That's actually a line from John Gall, who wrote the Systemantics book that Matt talked about. Resilient systems continue to operate in failure mode. Even when things are failing, they still work. So a culture where this is what that whole fail fast stuff is about. It's not about crashing. It's about continuing to be working in production even though something's failed. That's what it's about. And I think I heard Lou talk about it. I know Matt talked about it. And it's this notion of experimenting, too, setting up a situation where you can experiment without breaking things. So we won't have a chance to look at this, but this is another diagram from the ETTO book. And this is this notion that some things are loosely coupled and some things have really complex interactions. And when you're tightly coupled up at the top and have complex interactions, like a nuclear plant or an aircraft or a space mission or something like that, one small thing goes wrong, boom. Right? That's what's so dangerous about power plants, right? Nuclear power plants, because there's such a tightly coupled system. But if you can get down in here, where it's loosely coupled but still complex, mining and R&D and military and so on and so forth, you can survive mistakes, you can survive failures and continue to keep working, right? So it's an interesting model. I've seen another one that actually uses IT kind of concepts. Here, I couldn't find that one for this talk. But thinking about this interaction to coupling, this complexity model is really important. You'll hear lots of people talk about loose coupling. I'm doing a talk on it tomorrow. And it's because of this. It's because what I want to do is survive the failure, not prevent it, because I can't prevent them. It's a sort of a variation on the theme, you can never make a system idiot-proof, because idiots are so damn ingenious. Like, I never thought anybody would try to do that, right? But they do. So really, the enemy here is intractability. And there are 3 reasons. Because systems keep getting bigger and bigger, because the rate of change gets faster and faster, and because expectations keep rising. This sort of explains our job position, right? Right? People want more, they want it faster, and they keep coming up with new things all the time. That's the intractability we talked about earlier. So that's what continuous delivery is about. That's why continuous delivery, as Matt pointed out, is one of the prerequisites to building a Microsoft culture. Because I need to continuously deliver, and I need to be able to continuously deliver in production. and I need to survive when one of those deliveries actually fails without killing production. This is a whole concept. Reducing the cost and getting that ERI early and improving the quality and all that time to market comes from adopting this second law, this notion that we can always do it over, and we do it every day. Remember Lou was talking about the difference between 6 months and then every month and then every week and then every day. And places like Etsy and Netflix and all these other people, they do it hundreds of times a day. They post to production. That's because they can afford it. They survive that. So Conway's second law tells us that the size of the problem is incredibly important. We need to make the solution as small as necessary. Right? The advantage of releasing 360 times a year is not that I get to go through the same pain I do every 6 months, is it's because the pain is incredibly reduced. Right? When I do a release every day, there's maybe only 5 or 6 fixes in that release instead of 500. So if something's going wrong, the math is much simpler to figure out which one's causing the problem. I don't have to just like point and go like that and hope that it comes back up on Monday. So this continuous delivery pattern is exactly what Etsy does. So this is a graph of what they work on. How many deliveries per day, and up and up and up, and you can see it goes up. Deployments per day is in the 40s or 50s in average. By the way, what I find really fascinating, it's a little hidden in this graph, the dark color is config change. They've actually over time developed a system where most of their deployment is changes in config, not code, which is another incredibly brilliant strategy because that's a lot more tractable than the code. So if you or your team can't explain all the code that's about to be released, then that release is too big. It's as simple as that. If you cannot tell me what's going on there, then that release is too big. And I doubt any of us could figure out explain what's actually in that 6-month release. So execute small releases instead of a few large ones. I think it's John Allspaw from Etsy. I think it's him, maybe one of the other guys. He says, one of the things about DevOps is if something hurts, do it more often. Figure out why you can't automate deployment. Figure out why deployments keep going badly, and sort that thing out. Because that's an incredible weapon. It's a powerful tool for adding resiliency to the system and dealing with this second law. Okay, Conway's third law, this is a little tricky. There's a homomorphism between the graph of a system and the design of the system. There's a similarity, there's a fidelity, the way the graph of your organization works versus the graph of what they produce is identical. It's this notion that I can transform between one and the other without losing any fidelity. And he explains it like this. This is actually a diagram from the paper. This is back when they were doing things on large mainframes, and they would have some people working on the user side and some people working on the system side, and they would say, this is the way the actual thing's going to be used and work, and this is how it's actually organized. They would be organized the same, and teams would end up being organized the same. The design team and the actual produced system looked the same. It's explained a little easier in the Hacker's Guide by Eric S. Raymond, back when you built compilers in the 80s and 90s. You got 4 teams, they're going to get a 4-pass compiler out of that thing. If you break into 3 teams, how many passes? 3, right? You have the power to decide what's going to be produced by creating, creating these organizational elements in your group. Conway's third law is actually about cross-team independence. What happens is teams work as independently as they possibly can for as long as they can. Again, Lou gave you some great examples of this in the morning. Each team should be fully independent. Each team should be able to operate independently at their own speed. Agility doesn't come when you can get 5,000 people all around the world to run at the same time. You never will. Agility comes when you can get those people into small enough groups that they can each run at their own pace. Today slow, tomorrow fast, the next day a little bit slower, a little bit faster. They can all run at their own pace. That fully independence is incredibly important. If you have to hold a release until some other team is ready, you're not an independent team, and you're not going to have the agility to respond. This is an incredible challenge. This is some information from another Microsoft research project about dependencies. We've built up a whole culture of dependencies. We even have tools to manage them and tell us about them. I would say that it's much better if we actually just kill them. I don't need a tool to manage them. I need to get rid of them. So they had a survey of, I think it was like 700 or something like this, project leaders, and they asked them, how do you deal with dependencies, cross-team dependencies? And I had some very interesting answers. I was a little creeped out by these. Oh, I deal with them by avoiding unreasonable people. I only interact with people I trust, and I just cancel the project. Wow. By the way, at 10 and so %, that's like 75 people would answer that. I actually like these better. I like to focus on these. I minimize dependency. I have a backup plan in order to ship without it. I eliminate codependencies, and I never take them in the first place. These are people who are managing their organization, managing their model, and managing the complexity of what they're doing. I especially like that idea about having a backup plan so I can ship without. That's true interdependence. Okay, let's do one more. Conway's fourth law. This was about disintegration. The structures of large systems tend to disintegrate faster than small systems. The larger they are, the harder they fall. And he cites 3 reasons for this. And the first one is that when the system gets really large, and there's lots of pressure inside the culture to assign more people, and we already know how that works out, right? Adding people doesn't help. The second one is when you have these larger groups, the communication gets worse, right? The math goes up. So all of a sudden, it's harder to communicate, and that affects the output. And a lot of that has to do with this idea about how we can communicate with each other. Then finally, they have this idea that they're similar. The organizational structure and its communication structure are the same, and that's that communication dictates design part. We know this experience. Really large projects tend to fail. I'm on a project right now. The reason I have this is because I'm losing a bet. I'm losing a bet with my publisher. I'm working on a project, and I said, I will not shave until I finish this book project. Well, something terrible happened. I missed my deadline, and now I've missed my deadline to the point at which I'm starting to think about other things I probably should have said or done, and there's that goofy thing called time, where other people that I can't control have also said and done things, so that some of the stuff that I wrote about 3 months ago has actually already been said better than I could. So what's happening? My book is suffering from feature creep. All of a sudden, I can't release my book because I took too long. It's now got to be a different book. My customers, my stakeholders, my publisher and my audience, they need new features now. They don't need those features that we outlined 6 months ago that I didn't get a chance to build yet in release. They need new features. The business rules have changed. We all know this experience, right? By the way, if you watch, hopefully this will be shaved in the next 30 days. I can move on with my life. But communication dictates design, and the larger it is, the worse it gets. Time is against large scope in any kind of system, whether it's people or code. That's why we do short release cycles. That's why they need to be small, because we need to release them very, very close to when they were requested. We need to shorten that feedback loop. This is a great graphic from the Standish Group. I don't know if anybody remembers the Standish Group. They've been at this for about 20 years, documenting what they call large projects. Size on the left, complexity on the top. We won't go into exactly what their metrics are, but what they're basically tell you, if it gets really big and really complex, you're going to fail. You might survive some middle space. If you can keep the size and complexity down on at least one axis, you've got a chance that this project will not fail. Every month we read in the trades about a gigantic project that failed. Did it fail because they have a bunch of idiots coding? No. It failed because their scope was way out of line. They were never going to make it, and it starts dragging out, and before you know it, even when they get done, nobody uses it. We have these experiences. We know these. If you are missing your release dates, you're probably trying to take too much scope. Your scope is too big. Cut it down. What we say is aim for a scope that supports a release cycle of 2 weeks or less. 2 weeks or less, even if that's only just one bug fix. 2 weeks or less. I've worked on a lot of remote projects, and I did some work with Microsoft years ago, and Microsoft actually had a simple metric, and that was you released every week, and if you missed a release, they called you up. You missed a release. What's the story? I know already. I know within 5 days that something's wrong. Not 6 months, not 3 months, not 4 weeks, within 5 days. And in organizations like Etsy and Spotify and Netflix and all these other, they know within a day. Oh, what the heck? The release is way down. Like, where is this? So this is incredibly important. By the way, this is Mel's current mugshot. Conways Laws can actually help us succeed when working in these microservice environments and working with teams. So if we remember the first one, the systems design is a copy of your communication. This gives you the power to start changing the way your communication structure works, changing the size of your teams, changing where they physically are. You can actively manage communications within and across teams, even when they're remote, even when they're in Europe or Australia or India or Brazil. You can make a difference here. This is some material from 2 individuals working at Bell Labs, and they say what happens in remote situations is you got 2 issues of complexity and uncertainty. So you want to reduce complexity. That's making the size of the problem small. We've talked about that already. And you also want to reduce the uncertainty, and that's increasing the quality and repeat of communication, increasing communication channels. Smaller packages, more communication. Dunbar, by the way, when he talks about that group of 150, he notices in primate cultures that have a size of 150, 40% of the time in the group is spent grooming each other. That's called overhead. We all know what overhead is, right? The more people, I got to have more meetings, I got to have more of this, but that's overhead, right? So if I can increase the quality of communications, I win. So how do I do that? You'll find most open source groups do this right away. They always have a chat tool open, even in their writing code. In our group, in our API Academy group, we have a Slack channel. It's open almost all the time. That's how we talk to each other, even in an asynchronous way. A lot of organizations say commit to video conferencing for remote workers. PayPal has this rule that basically says if you work remotely, when you go sit at your desk for the day, you turn the camera on. Not because they want to make sure it's your desk, but it's so that people can see, your other team members can see you're actually there, so they can sort of mimic this walk-by experience. Like, oh, that's right, Susan, I wanted to ask you this question about the code you just wrote, right? I don't have to schedule a meeting, I just see you right there. Online forums and news groups, you'll find lots of tooling and product gives you this notion of being able to talk to each other in online groups in some kind of way. Why is GitHub so successful? Most people say GitHub is so successful because it's so social. There's lots of discussion possibilities. Wikis and websites, make it easy for people to contribute. That's our challenge all the time. Make it easy for me to just like type some things in and grow this material. If I get an idea, write it down. I don't have a lot of ceremony between here and completion. All of this is to reduce the effort to locate and interact with the right people at the right time. We're closing the loop, trying to make that smaller. Communication is incredibly important. Connollys Second Law, there's never enough time, right? We'll always do it over. That's really about this notion of accepting that our process is continually repeating. Matt talked about this earlier today. We had this discussion last night about, is it ever over? Well, no, actually it's not. It's never done. There's always something else to do. So Jez Humble, the person who really is sort of the thought leader on this idea of continuous delivery, writes that the core concept is testing at every step, reducing the risk inherent in deploying. I want to reduce the risk. I want to make this easier and easier and easier. So this becomes part of your culture. This becomes part of your feature. So how do you do this? You implement those small changes. You test immediately. Lou made a big point about that. Test-driven development is a real habit in these DevOps and microservice cultures. You deploy constantly. Deployment is not this amazing, crazy, risky thing. It's, deploy. Did you deploy? Yeah. Oh, didn't even notice. I think it's Etsy. The first day you're on the job, You deploy into production. You deploy something into production. There's a little button. They say, oh, you press here, and you deploy into production, because that's what we do here every day. If I remember correctly, there's a big hazing ceremony. When you press, the lights go dim, and red things go off, and they scare you. And they say, now you're in the club. You know? But deployment is important because it shortens the feedback as much as possible. The smaller you can make it from request to delivery, the better the quality of information. I couldn't find the source of this quote, but the latency between execution and results is an indicator of how dumb the system is, right? It's one of the reasons we have problems with weather and economics and all these other things, that it takes sometimes months or maybe years to see the effect of what I just did, right? But if I can shorten that, I can see the effect much sooner, and I can learn much faster. This idea of homomorphism, this like similarity between the way your group looks and the way your output looks, organize teams to achieve the desired system. You know what? I need an independent printer component. That means I need a printer team, right? You know what? The problem is I've got 3 developers in Argentina by themselves. Make sure that they're an independent team. Don't try to get them to work on some other project across some other time zone. Give them a chance to build something that they can operate on their own. So this was talked about a lot this has really become sort of like the major microservice chatter. This idea of sort of reverse Conwaying, like using Conway to set things up. And Martin Fowler has documented a lot of this rather nicely. He talks about organized around business capabilities and products, not projects. I'm in charge of printers, not the database, right? Database is vertical, or database is horizontal, printers is vertical, stuff like that. I think Lou talked about this. And I think you already saw this graphic, so I won't dwell a lot on it. Instead of taking about these specialist groups and keeping them segregated from each other, you create these cross-skill teams, and they're able to build material that actually reflects all those pieces. And we saw some good examples that Lou had talked about already. So organizing by product or business unit means I combine design and develop and test and deploy. That includes storage and business process and UI, all as part of their responsibility. That doesn't mean they all have to be physically there. Lou gave us some pretty good examples of how things might be staged in different places, but they're still owned by the same group. You give teams autonomy within their boundary. This is where we're getting the nonsense about polyglot programmers. Like, I should use any language I want. If I want to use Go, then I'll use Go. Is this notion that people are focusing on this autonomy. Now, you know, there's a point at which, I'm sorry, I forget who I was talking to today. You can raise your hand. They had this sort of thing going on, and some team created something with Mongo and Node and a bunch of other things, and then they handed it over to central deployment, and it was like, we don't support any of that. You didn't talk to us about any of this, right? So this is not anarchy here. You can't just go run off and do whatever you want to do. But you want to give folks as much autonomy as they possibly can for lots of reasons, including work-life quality. Like, look, if you just want to, you're just going to tell me how to do my job, you can get somebody else to do it. I don't need that. I want to take advantage of your talent. Require teams to interoperate, not integrate. This is really important. Interoperating means that we can negotiate something, we work something out. All sorts of protocols like HTTP and these other things are all built on this notion of negotiating formats, negotiating protocol levels, all these kinds of things. And that's the way we need to build our complex systems. That allows people to run at different speeds. That means I don't have to do everything perfectly. That means if you change your part, you don't break my part. So this all becomes part of this work. And apparently there's another point that's important. Well, I'm going to continue even in failure mode. Yes. So make sure your teams own their complete life cycle. Now let me tell you, I'll give you just a short one. John Allspaw at Etsy was looking at this material, and on this one in particular, he asked me, okay, Mike, we want teams that are autonomous and they have everything they need. He says, when you're building your teams, how many people from HR do you put on that team? How many people from finance? He's got a really good point, doesn't he? So this isn't just like, I'm just going to take a handful of people from everywhere and put them all on the team to go make the printer driver, right? There are skill sets that we need to account for. But making sure they have autonomy, making sure they own their zone, their product, their unit, is incredibly empowering and increases the quality. So finally, this idea of structures tend to disintegrate. Large structures tend to disintegrate quicker than small structures. That's why you keep the teams small, because they don't creep, they don't build things that they can't support anymore. They sort of stick to their knitting. Probably you've already heard this one. I think Lou already brought this one up. So this is the Jeff Bezos meme about the idea of what's called 2 pizza teams. The story is when he starts pushing for services everywhere, his architects start complaining, well, we're going to have a lot more meetings. And he says, no, you're having meetings because you got too many people in the room, too many people trying to do this. I don't want teams that are 2 pizza teams. If I can't feed them with 2 pizzas, then that team's too big. That's his metric, right? Of course, those are American pizzas, so, you know. Guys in Europe must have got really upset when they saw this. So but this is all around that same idea about, look, if it's too big, it's going to fall over. And you're not going to be able to move it quickly enough. So make teams as small as necessary. Resist the urge to grow teams in response to deadlines. And that has to start with all of us. Like, I cannot ask you to add more people to your team in order to get this deadline done, because that's just doesn't make sense. And you need to tell me no if I ever try it. Consider Dunbar's groups when sizing teams, Dunbar level 1 and 2. Be prepared to break into smaller teams. This happens all the time. Lou sort of gave us a sense of this. So what's going to happen is we're going to be adding features and features, and I need more people. And pretty soon, you're like Albert Gore from Gore-Tex, and you say, you know what? We need to split this team up. We need to split this team up. You guys over here can work on the front end of the driver, and you guys can work on the back end. And now you get that same agility, that same trust, that same power of speed. And it's better to be too small than too big. If you're too small, if people are constantly saying, man, I need one more person. I could get another feature in every day if I just had one more person. That's a good problem. I just don't know what I'm going to do with him. He just sits there all day. That's a different problem, right? So Conways Lessons, increase communications, support continuous process, organize teams by products or with your end product in mind, and make them as small as necessary. This is fostering that kind of culture that's going to be able to operate well in the sort of microservice space. This gives you that agility, that resiliency, and even the opportunity to increase the quality without increasing the cost. The biggest challenge for us is not technical. It's social. And it's a big challenge. But it's one, there's lots and lots of material. So I have a reading list that has at least half a dozen books on it. The thing is, most of us have to kind of get out of our comfort space. We're not reading an IT book anymore. We're reading something else. But there's lots and lots of material that goes back half a century or more on this that can help us figure out how to do this. And what we'll try to do is share with you more and more as we learn from teams, as we talk to people. And you can share with us what your challenges are, because that's a way to start creating these effective teams. And that's what I've got. Thanks.